Thank you, David and Larry. We appreciate your prepared remarks, but we really want to be involved in some discussion about this. So I want to ask my friend Hoxie Smith, the Director of Energy Programs at Midland College, to come and facilitate and moderate this discussion and questions.
Let me jump in front before Hoxie gets up here. I failed to mention this earlier. There are note cards on your table. They look like postcards. And the intention of those is for you to write questions down. And we have some people who are collecting the questions around the room. So if you have any questions, please write them down quickly. While you're doing that, I also failed to point out that we have a number of very important participants in today's conference, and that is the students that have come here. I'd like all the students to raise their hands, the students who are here. I know there's some here in the front and back. There's a contingency from New Mexico Tech back there. Employers, look at who raised their hands. These are your future employees. I encourage you to seek them out and start to talk to them and find out how you can get them interested in your company. So with that, if you want to fill out your cards, Hoxie, I'll turn it over to you. Thank you.
Thank you very much, Van. It's sure a pleasure to be here today, and we certainly have some interesting issues, very timely, obviously, for this conference. And I think that, certainly talking about wind and solar are on the forefront of the energy policy issues today, along with climate change and everything that's going on in Washington, D.C. I'm from Midland College in Midland, Texas. Of course, we're like Hobbs. We're surrounded by a lot of oil production here in the Permian Basin. We produce 20% of the crude oil domestically for the country. And so we're usually focused on oil and gas. But renewable is certainly a real ace up our sleeves. We have so much solar. We have so much wind. And we, of course, right now, the tremendous job that the Lee County Economic Development has done in this area for developing nuclear energy. So, with all that said, we'll start asking some questions. I have a few questions right offhand myself for Mr. Flowers. And Larry, obviously, you've done a lot of work in wind energy development and technology. In West Texas, we have a lot of wind farms that have gone up over the last 2 or 3 years, or 3 or 4 years. And what we're running into right now is a huge problem on the transmission grid to be able to get thermal, reliable power back to the Metroplex in Dallas-Fort Worth from West Texas. That's thermal, that's reliable power from natural gas or coal. We have so much wind energy power coming in that there's just a big bottleneck. So recently with the CREZs are the Cooperative Renewable Energy Zones that have basically a preference or incentives to get transmission built out in rural Texas. We are trying to get more transmission. This seems to be a huge problem. And certainly if we start building wind farms all the way from, as Boone Pickens would say, Sweetwater to the Canadian border, we're going to have a lot of issues with transmission infrastructure. Can you comment on that for just a moment, if you see that as the biggest problem in wind energy development?
Yeah, transmission is a big challenge, and one of the biggest problems with transmission, well, there's a number of issues with transmission. One of them is it takes a long time to plan and site and build transmission. You can build wind farms, as I mentioned, in 6 to 9 months. It takes about 2 years to go through sort of the permitting process and building. So we have a mismatch between building wind and building transmission. And so what Texas did very creatively, and we're copying it in Colorado, and we're actually copying it in the Western Governors Association, the whole West, is they said, we know where the wind is. It's over here in West Texas. We know where the loads are. So why don't we start building the transmission and figuring out a way to get cost recovery to those people who build transmission in advance of actually having the generation. So we can start planning and building transmission now to those resource areas where we know the wind is, so that by the time they build it out, the wind development will come on stream And as you go along, you are providing cost recovery to the transmission builders. So that's one of the biggest issues, is the mismatch in the timing of the two construction processes. The other thing they did creatively in Texas as well, which they haven't done very well in the rest of the country, is what they call socialize the cost. In other words, transmission, they say, benefits the reliability of the system, and therefore everybody benefits, therefore everybody pays their piece. As opposed to in many other states, as you build a new generation facility, say a wind facility, if you need to increase the capacity of those lines, that next generation facility has to pay for that upgrade, which many times puts an adder on the project that's not affordable. So they also came up with a creative way of paying for it. So they call it the 3 Ps, the planning, the who pays, and then the actual permitting process. And these are all challenges in transmission. In the western region of our country, which has a lot of load growth and has certain places where the wind blows and certain places where it doesn't, the real challenge is working together, because we have no ISO or RTO out here in the West that works together to plan and implement and pay for transmission. We have a real challenge. And I have to say, the Western Governors Association has now gotten together, recognizing that they have to work together in order to get this transmission planned, permitted, built, and figure out who's going to pay for it before we start building a lot of wind facilities. End up with West Texas, where you have to curtail some of the wind, because when the wind, once it's built, you have no fuel cost, so it's the lowest marginal cost resource. Now, I want to turn to my colleague from Southwest Power, because they have to face this issue as well. So I think he probably has actually a more legitimate answer, or conservative answer.
I guess what I would say is, from this building, we're about 45, 50 miles from the center of the 3 grids. We're kind of on the edge of the electric grid and the eastern interconnection. ERCOT, most of Texas is separate, completely isolated except through DC ties. And the western grid, we connect to the western grid at DC ties at Artesia and up by Portales. This is ground zero for renewable development. It's where it will occur. We have tons of wind interconnection, new projects coming on, but we're on the edge of the transmission world. So transmission will be built, High Plains Express or something else in the west to move power to California. It'll be built in the eastern grid, the EHV, the extra high voltage overlay, DC lines to move power to the eastern seaboard, and the CREZ lines to move power down into ERCOT. So the renewable energy will grow here, and there will be massive transmission that needs to be developed, frankly, all 3 directions, to move power into the west, move it into ERCOT, into downstate Texas, and move it into the biggest grid, the eastern interconnection.
And let me just mention one other thing. First of all, it's not Southwest Public Power, I'm sorry. It's Southwestern Public Service, part of XL. Is that people talk about the cost of transmission, and it is expensive. But compared to generation and distribution, when you integrate it all, it's less than 10% of your bill. And our 20% wind, we're talking about $500 billion in wind generation and about $60 billion transmission. So it's a transmission actually, compared to the generation and distribution on your bill, is at less than 10%. So it's expensive, but it's relatively modest when you look at your overall bill.
Okay, thank you very much. I've got plenty of questions here, so we're gonna have a good discussion. David, I've got a question for you now. This one says, please address the issue of natural gas backup to CSP and molten salt storage aspects.
Today, we operate the power system with a lot of different kinds of generators. We have gas-fired generation that operates a little bit in the winter, but primarily comes up to meet summer peaks. All the wind power that's been put onto the XL system is backed up primarily by gas. Initially, the first few hundred megawatts of solar, it won't be a problem to back it up with gas. But in some parts of the country, and as you get more and more solar, when we get to a point that we have thousands of megawatts of solar like we do currently thousands of megawatts of wind power, the central solar projects with storage will provide a lot more value and allow the utility company or the marketplace to avoid the installation of that redundant capacity.
Okay, thank you very much. Unfortunately, we only have time for a couple more questions, but I'm going to go ahead and try to grab a couple of the most interesting ones out of here and keep them separate. For Larry and David, again, both of you, what are the construction costs per kilowatt hour for solar farms and wind farms? And do you have any data comparing those construction costs to that of nuclear energy?
Well, I can talk a little bit about wind. I'm not going to, the nuclear question is a big uncertainty because we haven't built a nuclear power plant here in the U.S. for quite a while, and there's real questions about what that costs were. Black & Veatch, who we rely on, who's a big A&E firm in Kansas for our non-wind costs, thinks nuclear might be 12 to 15 cents a kilowatt hour, but that's, again, a big uncertainty because we haven't really built one. Wind varies dramatically depending on the wind resource. And I showed you those graphics that in West Texas or in southeastern Wyoming, where you have class 5, even class 6 wind resources, the price it can be pretty low. In Lamar, but that was again many years ago, we're talking about 3.3 cents a kilowatt hour in that range. Today, because prices have almost doubled, I mentioned we used to be $1 million a megawatt. We're closer to $2 million a megawatt now. 6 to 8 cents is the range that you hear of. Now, a lot of these dynamics, the supply-demand issue, the euro-dollar issue, the commodity prices, are all changing very rapidly in this economy. And so projecting out is going to be very difficult. We do believe that long-term we can get those prices down to $1,600 a kilowatt, 1.6 million per megawatt. That's what our future, we think, with advanced materials, controls, and design. So we think it's going to come back down once these things settle out.
I would just add, the question was really about capital cost as opposed to cost per kilowatt hour. If you think about it, solar is going to generate at somewhere between 25 and 50% capacity factor, even with storage. Nuclear, once it's operating, is going to run at 90%, basically take it down for refueling outages. Capital cost nuclear, I think probably in the $4,000 a kilowatt or $4 a watt range, plus or minus a little bit. Solar is probably a little less than that, but you're only going to get half the kilowatt hours out of it.
Okay, I'm going to just ask a few more questions. Obviously, there's been so much going on with nuclear energy, with the LES facility here in New Mexico, and a lot of the other things that are going on in this area to help promote nuclear energy. I have quite a few questions. I have a whole stack of questions here on nuclear energy. And basically, I guess the main theme here is we can develop nuclear energy which has no emissions, no greenhouse emissions. We can develop that, and we can have reliable thermal power that we can build these plants on the grid. Now, why would we want to go ahead and base our future on renewables that are less efficient, require a much larger transmission build-out, and are not reliable? In other words, on a hot day in the summertime in the afternoon when everybody's turned on their air conditioner, that's the least likely time that the wind's going to be blowing. Again, with solar, we found that the off-peak hours is when the solar intensity is more. So until we have some breakthroughs, certainly with storage technology, to be able to store this electric power and use it when we need it, why would we want to be putting our eggs in the basket now? Why aren't we concentrating a little bit more on getting some of these nuclear plants up and running? Either one of you.
I'll speak to that. Xcel has two nuclear plants. They're both in the upper Midwest. We're repowering them and extending their lives, relicensing them, and getting more power output. But we have not actively undertaken the development of a new green or brownfield unit. We have a clear view that the answer to global climate change, to being proactive in reducing our exposure and our customers' exposure to future taxes, cap and trade costs, environmental costs, the clear answer isn't any one technology. The clear answer is, I don't know how many people have seen, EPRI developed a really good, Electric Power Research Institute developed a really good visual that shows a fan basically with building the components, conservation and load management, wind power, and then solar, integrated gasification, clean coal generation, nuclear, storage. All those technologies play a role. And it's like if I was going to start an airline, I shouldn't use that example because Southwest just has one kind of plane, but you'd want different kind of planes for long distance travel versus short hauls and smaller, basically you build a portfolio of generation to meet the total needs of customers. One distinct difference is we're going to do solar. We're going to do 50 megawatts of solar, emission-free, carbon-free by 2011, or 45 megawatts. Next nuclear plant, if we got really aggressive, is probably 10 to 11, 12 years away. It's also a huge financial risk. It's a very, very big investment and with an extremely long lead time, subject to inflation and all the things that could change during the interim. We think it's a big part of the mix, especially for parts of the country that don't have abundant renewable resources, like the southeast and the eastern part of the country. But there's a big difference in terms of when it can be done and the amount of risk associated.
And I just add one other thing as a consideration. You saw the graphics of what the Southwest is going to look like as far as temperature and evapotranspiration. When you look at the combined forces of growth in the Southwest, as far as municipal water supply, you look at the needs for cooling thermal power plants. The conventional nuclear plant consumes maybe 700 gallons per megawatt hour, and then you look at what's happening to irrigation. And then on top of that, they're developing a lot of corn ethanol projects up in the northern part of the Ogallala Aquifer in Kansas and New Mexico. Nebraska. We have a water crisis, in the West, and we need, if we're going to do nuclear, we have to figure out how to do it with dry cooling, and what the impacts of dry cooling are going to have on efficiency. So keep the water piece in the equation as we talk about nuclear.
Well, thank you very much, Larry and David. And I just have one more quick comment. I think, Larry, your comment on the water problem and sustainability is very pertinent. We certainly have a lot of water in the Permian Basin. Problem is it's not very good quality. So with technology, maybe we can help clear that up. But I do hear everybody that I know in the energy realm saying that we need a mix of everything. There's no one answer to this problem, and I just hope that the current administration will not rush to renewables without remembering that we have to bring all the others along with it. So I think it's a great discussion. Thank you so much for your time, and that's the end of our first panel discussion.
There was quite a number of unanswered questions. I'll assure you that those have not gone to waste. We're going to collect all these throughout the day, and we'll address unanswered questions on our website. So we'll entice you to keep on tuning into our website and look at the questions you haven't that weren't answered. But in addition to that, we're going to use these questions to shape our future conferences. If we get a lot of questions in one area, obviously that's something we need to focus on, and we'll have focus for that in the future. At the end of the day, we're going to talk about what is going to happen with the Policy Center as we move forward. With that, we do have time for about a 10-minute break.